All right, you guys, last one. So we are taking an equation and we need to make a table. And this is one of the very first things we did with quadratics. Make a table and a graph. And again, once we have the graph, you can kind of just think to yourself, what would be a situation where I might see this, okay? So what's happening here is I can always make a table. You can either if you want to be technical about it and if you are allowed to use a calculator, enter this equation into the y equals. Let me clear out what I have in here. Okay. This is the shortcut. Maybe I'll show you the shortcut after. Now let's just show you the shortcut first because we've done a lot of this. So we put x squared plus 5x minus 2, and then we just go to second table. Now, which part of the table is important? It's important to get that curve. So we want to know where it switches from up to down or where it switches from down to up. So let's see. We can tell -2 to 4, these are all going up, and it's going to continue to go up. So I think we need to go backwards a little bit. Okay, I see it, you guys. So y here is positive 34, and then it's going down 22, 12, 4, then -2, -6, -8, still going down, but look right there, -8, -8. Now it's stayed the same. So I know in this particular case, my vertex is going to be in between -3 and -2. And then from -8 to -6, okay, it's going up here, right? And then to -2, that's also going up 4, and it's going up. So I need to start, let's start a couple below, like 3 below and 3 above. So -6, 4, -5, -2. Now, where are these numbers coming from? I'll show you. Let's see, -6, positive 4, -5. Well, I don't have the calculator in front of me. How could I have figured that out? I just input that -5. That's my input. Remember, x is my input, y is my output, o. So I have -5 squared plus 5 times -5 minus 2. So -5 squared is positive 25 plus 5 times -5 is -25. So check that out, you guys. That just cancels. Positive 25 plus -25 minus 2. So my answer is just, if my input is -5, my output is just -2. Does that match? Yep. Look, I'm going to arrow down to -5. If I input -5, my output's -2. Okay. If I input -4 squared plus 5 times -4 minus 2, I'm going to get a smaller negative number. -4 squared is going to be positive 16, but 5 times -4, that's going to be -20. So I'm already at -4. 16 minus 20 is -4. And then I take 2 more away, and that's going to equal -6. So -4 is -6. And then -3, that should have been the -8. And then -2, that was also -8. And then -1, let's see, whoops, sorry guys. Why did my calculator go so far away? -1 is -6, and then 0 is -2. So -1 is -6, 0 is -2. So that's my y-intercept right there. Okay, so I've created my table, and I just used the calculator, but I also showed you how you input and output if you wanted to just solve it by hand, depending on if you are working on a question where you are allowed to use a calculator versus you're working on a question where you are not allowed to use a calculator. Okay, so what's next? I've created a table. Now I need to create a graph. So, whoops, I erased, what was that, -2? I really haven't found any other good points besides my y-intercept. So let's see what I have so far. I have my y-intercept, which is negative 2, so I know that's here. And then I know that negative 3 is negative 8, and I also know negative 2 is negative 8. So 1, 2, 3. Negative 3 is 2, 4, 6, 8. Negative 8. Down here. So that's a point. And negative 2 is also negative 8 here. And I know my vertex is going to be in between here and here. Well, really, to get all of these points, it's going to look like, let's enter in this, if this is negative 2, this is negative 2.5. Let's actually enter in negative 2.5. And we can do that in the calculator by doing second table set. And right now, it says I'm starting at negative 6 and I'm counting by ones. If I want to get that 0.5, I want to count by 0.5s. And then let's go back to the table and I'll go down to negative 2.5. And it looks like my vertex is going to be negative 8.25. The reason I chose negative 2.5 is because that is right in the middle, okay, of negative 3 and negative 2 of those two 8s. Okay, and that's going to be, and that, remember, I saw that it had gone here and gone here, so I know my middle is going to be, and it was negative 8.25, wasn't it? Let's see. Negative 8.25, okay. So I know that's going to be there, and that's negative 8.25, negative 2.5, comma, negative 8.25. Okay, so if it's going to do this, right, and I know I'm going to have a y-intercept over here, and probably over here. Should we go look at that table and see if I can find those y-intercepts? I need, or I'm sorry, x-intercepts, so I need y's to be 0. And it might not be there. We might have to solve this equation. Yeah, I'm not seeing it. So let's solve this equation for y is equal to 0, and that'll give us our x-intercept so we can finish this graph, okay? And this will also be a good way for us to practice completing the square. Whoops! I don't want to do that. I just wanted to erase a little bit. This will also help us practice some completing the square, because this equation is not, oh, that's weird. This equation is not factorable, right? So we have x squared plus 5x, and I'm going to move that negative 2 to the other side, so I'm going to plus, leave a space, equals, if I added 2 to both sides, this is going to be positive 2 plus 0. You know what? I'm going to back up and make sure you really understand how to complete the square. 5x, let's just do this from the start. First of all, we need to set this equal to 0. Then add 2 to both sides and leave a space. Okay, so that's why this happens. Equals plus 2. Leave a space on both sides. What you do to one side, you have to do to the other. Take half of 5, which is 2.5. Square it, which is 6.25. See how I did that in my head? So 2.5 times 2.5 is 6.25. And you need to add that to both sides. Okay. Now, we are going to factor the left-hand side into a perfect square. If I have done everything correctly, all I need is that half of 5. That should always be, not half of 5, but half of b should always be the number in this perfect square, because 2.5 plus 2.5 is 5, and 2.5 times 2.5 is 6.25. So we factored it into a perfect square. That's the entire reason that we did this. Then simplify the other side, and positive 2 plus 6.25 is positive 8.25. Okay, here we're going to solve. And we got to take the square root of both sides. And that's x plus 2.5 over here. All that happens when I take the square root of this side is we get rid of that 2 as the exponent, equals. And I know this is not a perfect square. I'm not ready to solve for it yet. I'm just going to put plus or minus 8.25. Okay. Then minus 2.5 from both sides. And we have two answers. x1 equals And we're going to use, whoops, what did I do? x1 equals positive 8.25 minus 25, positive square root 8.25 minus 2.5. And x2 equals, I'll show you guys here, I'll do this. We know that positive went here, and then let's change our color. The negative is going to go here. So x1 is the positive, x2 is minus the square root of 8.25 minus 2.5. So a lot of people get confused and they want to change this part to plus and minus. No, it's the square root of a positive number that gets changed. So let's use our calculator to solve these, because I want to know where it's going on that graph. Okay, so in my calculator, what that looks like is positive, well, let's do the negative first so I can just delete that. Negative square root 8.25. In this case, I'm going to put a parenthesis because I only want the square root of that number, not of the next number, minus 2.5. So negative 5.37 is 1. So that's going to be negative 5.37. And then this other one, oops, I did that wrong, you guys, because check it out. I put in the negative first. Remember, I even said that, negative 5.37. And then the reason I wanted to do the negative first is so I could just go back and delete that negative and then hit enter. And I get positive 0.37 approximately, right? Both of these are approximately positive 0.37. And that's what these are right here. The blue answer is going to go there, and that's negative 5.37. And the yellow answer here, and that yellow answer is plus 0.37. So that wasn't going to show up in our table, right? So 0.37 and negative 5.37. And these are approximate numbers, right? But I know the middle of those two numbers is negative 2.5 because that's our vertex. All right. So we have our graph, we have our table, we have our equation. We started with our equation. Right, here's our equation. That's where we started. We want these two. And again, situation. So what's happening here? What could we say is happening here? Again, this isn't really going to work for bouncing a ball like before because it's not hitting the intercept and bouncing back up in this particular picture. But what could be happening is, again, something that you are trying to model, like a piece of architecture that you're trying to model with a quadratic, or also anything that's going to have a minimum value, okay, that's going to go down and then come back up. I'm trying to think of a real world situation. I bet there's a lot of science situations I don't understand that use like chemicals and stuff. Real world that you're actually going to be on the street and see is going to be hard here because we have everything's happening kind of on this negative side. So a real world situation might not happen. But whatever you can think of, I would take it. And this was the last video I am creating. So let me know if you have questions.